Hi class, in lesson 1.2 we will be looking at physical models of factors and multiples. Learning targets for today, we will determine factor pairs using arrays and area models and classify numbers using Venn diagrams. Key terms to look for in lesson 1.2, area model, set, and Venn diagram. Please turn to page 16, problem 1, using arrays to plan displays. Speedy Builders specializes in creating shelves, desks, and cases for collectible items. Speedy Builders wants to make rectangular cases with individual sections to display model cars. They want to design different size cases to display various numbers of cars. Before they build the cases, designers draw arrays on grid paper to make sure mistakes are not made. Think about a case that holds exactly 12 model cars, with one car in each slot. Please answer number 1 and number 2 with your group. For number 1, the arrays that could be drawn would be 1 by 12, 12 by 1, a 2 by 6, a 6 by 2, a 3 by 4, or a 4 by 3. And for number 2, the arrays drawn are the same as the factor pairs for 12. You can draw rectangles on grid paper to learn more about factors. Think of factor pairs as the dimensions of any rectangle using an area model. An area model for multiplication is a pictorial way of representing multiplication. In the area model, the rectangle's length and width represent factors, while the rectangle's area represents the product. Please turn to page 17 and answer number 3 with your group. Please note that number 3 starts on page 17 and continues through page 22. Here are the distinct area models for the numbers 1 through 5. Please check with your group to make sure that you have all of them listed and that you have all of your dimensions labeled. Here are your distinct area models for numbers 6 through 10. Please check with your group to make sure that you have all of them listed and that you have your labels showing on each model. Here are the distinct area models for numbers 11 through 15. Please check with your group to make sure that you have all of them and that your dimensions are labeled. Here are the distinct area models for numbers 16 through 20. Please check with your group to make sure that you have all of them and your dimensions are labeled. Here are the distinct area models for numbers 21 through 25. Please check them over with your group and make sure that your dimensions are labeled. And finally, here are your distinct area models for numbers 26 through 30. Please check them over with your group and make sure that all of your dimensions are labeled. Please turn to page 24 and answer letters A through D with your group. For letter A, the numbers 1, 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29 have only one distinct area model. What we know about these numbers is that they have factors of only 1 and themselves. For letter B, the numbers 1, 4, 9, 16, and 25 each have perfect squares as one of their distinct area models. These numbers have a factor that multiplies by itself. For letter C, the dimensions of each distinct area model are the same as its factor pairs of the given number. And for letter D, the case that students should choose for Speedy Builders should be dimensions of 1 and 12, 2 and 6, or 3 and 4. Please turn to page 26, problem 3, Venn diagrams. You have created models to show relationships between numbers. Sometimes when numbers are related in some way to each other, the numbers are called a set. A set is a collection of numbers, geometric figures, letters, or other objects that have some characteristic in common. Another model you can use to show relationships among numbers is a Venn diagram. A Venn diagram is a picture that illustrates the relationships between two or more sets. Venn diagrams use circles to help you put numbers into common groups. The example shown represents the natural numbers between 1 and 20 and the relationship between those numbers that are factors of 12, factors of 20, or factors of neither 12 nor 20. The numbers that are factors of 12 are in the region labeled factors of 12. The numbers that are factors of 20 are in the region labeled factors of 20. The numbers that are factors of both 12 and 20 are in the center where the circles overlap or intersect. And finally, notice that there is no label for those numbers that are factors of neither 12 nor 20. If numbers do not fit into either category, they are outside of the circles but within the rectangle. Please turn to page 27, answer number 1, letter A and B with your group. For number 1, here is what your Venn diagram should look like when it is completed for the factors of 15 and factors of 18. Please make sure to check over all of the numbers 1 through 20 and make sure that they are in the right spots. For letter A, the number in the overlapping region are common factors of 15 and 18. This would be numbers 1 and 3. And for letter B, the numbers outside the circles are not factors of either 15 or 18. Please turn to page 28 and answer number 2, letters A and B with your group. For number 2, this is what your completed Venn diagram should look like for the multiples of 4 and multiples of 6. Please check over all of the numbers between 1 and 30 and make sure that they are in the correct spots. For letter A, the numbers in the overlapping region are common multiples of 4 and 6. In this case, we have 12 and 24. And for letter B, the numbers outside the circle are the numbers that are not multiples of either 4 or 6. This will conclude lesson 1.2 on physical models of factors and multiples. Please let me know if you have any questions. Thanks.